This video deals with an annuity, but with a changing interest rate. And so the most important thing about this particular question is that you are paying 2,500 Rand a month for the first 5 years at an interest rate of 16.5% per annum, compounded monthly. So that means for the first 5 years of your annuity, your interest rate, 0.16165, and that is compounded monthly. So the interest rate for the first period is 0.165 over 12. Thereafter, what happens is the interest rate and the size of the monthly repayment change. So from this period on your timeline, okay, the interest rate we're dealing with here is 17.5%, and again it is compounded monthly. So I'm going to put that interest rate, 0.175 over 12, into memory B. Now we are being asked here what the size of P can be under these circumstances. All right, so our principal is still the loan and the interest that loan will accrue. So the first 5 years we have 1 plus A, 5 years, and it's compounded monthly. And then the other interest rate comes into play, and that lump sum would be subject to interest rate B. That's for a period of 15 years, and again it is compounded monthly. So that is the money out and the interest that would operate on that loan. It must be equal to the money in. So how much money goes in? Well, initially it's 2,500 Rand a month. That is interest rate A. We're talking about a period of 5 years, compounded monthly. And then that lump sum is subject to that interest rate for a period of 15 years, compounded monthly. We then have to deal with the payment size of 3,200 Rand. So 3,200 Rand. How many of those payments are we making? Well, it's interest rate B. We're making 15 payments, compounded monthly, all over B. And that is the calculation that you have to do. Right, so interest rate A, 0.165 divided by 12 equals shift store A. 0.175 divided by 12 equals shift store B. So we've put those two interest rates into our calculator. This amount over here becomes 1 plus alpha A, close bracket, raised to the power of 5 times 12, multiplied by 1 plus alpha B, close bracket, raised to the power of 15 times 12 equals. And this is 30,735. I'm going to take all those decimal places, shift store C. So I've put that number in memory C. So it is P times that number is equal to, and now we're going to work out what we get on that side over there. So we have 2,500 multiplied by open bracket, 1 plus alpha A, close bracket, raised to the power of 5 times 12. Subtract, subtract 1 all over alpha A. That is multiplied by 1 plus alpha B, close brackets, raised to the power of 15 times 12 equals. I'm writing these individual values down so you can check your answers as you go. So this is 312,507.75. I'm going to put that in memory D. And then this last part of the transaction, 3,200 multiplied by 1 plus alpha B, close bracket, raised to the power of 15 times 12, subtract 1 all over alpha B equals 275,2808.64. When we add those two values, plus alpha D, we land up with P times 30, comma, equals this value over here, 5878316.39, and so P is equal to this value divided by that value over there, and we get 191,254.05.